the working group can just handle those as an administrative thing. I want to be really clear. Most standards work fits this.
Alyssa Cooper, can you go back to the principles? I feel very bad about this because I saw like 8,000 emails about this before it went out, but the privacy of the network, that's kind of weird. Like, so I'm just telling you that when we approve this, before we approve it, I might suggest an editorial change.
That's fine, yeah.
They don't though, so.
I know, yeah, that was just, yeah.
Sorry for not catching that sooner.
Okay, just send us the change, or actually you can do the change yourself, right?
Yeah, I just didn't want you to be surprised.
Okay, yeah. Okay, Murray had something.
So in terms of meeting format, we're not meeting, AppState is not meeting this time at all, and as it gradually spins down, we have 3 documents left to process, and when they're done, I imagine Barry's just going to close that working group and we'll continue with this one. Okay. Some of the feedback we got as that transition is happening is that people really liked what we used to do, the Monday morning meeting where we would have the BOF summaries and the new working group summaries. People from lots of areas came to hear that. And so I think the plan with Buenos Aires is to reinstate that. So that would be the art area general meeting, and it will also include those things, but there will again be no protocol development of any kind going on there. If we're working on any IANA actions, we would discuss those. It'll be the general meeting and those summaries, and that will return for the Argentina meeting for the summaries and all that. I think that's going to be about all that happens at that meeting.
This is Ben. My understanding is that the summaries will be of new work and highlights, it won't be a general, we're summarizing everything the area is working on.
Well, sorry, I'm reaching across you. Occasionally, maybe art is too big for this, but occasionally we used to do, here's a summary of what every current art working group is up. Nope, never mind, it's being waved off.
Okay, so any more comments on the charter? Okay, so we'll make that one editorial change and it should be good to go then. Alan, you're up.
Okay, I'm Alan Johnson, and I'm presenting on behalf of Bernard, Andy, Laura, and Thomas, and we're going to be talking about opportunistic SR. Hold it. Is that better? Sounds better. Okay. Going to be talking about opportunistic SRTP. Next. So you probably heard of opportunistic security, some protection most of the time. The RFC was recently published by the Utah Working Group. Thank you, Utah, for doing that work and publishing a really good document that describes this approach. And essentially, it defines a third mode of security between clear text and full protection. And that is where security, whatever security is available, is negotiated and used. However, there is no failure if that security is not available. So this is essentially what opportunistic security is all about. And it's very important that you recognize that it's not a substitute for full security policies. Okay, those that want and have the ability to say we're always going to use full security will never have need for opportunistic security. So for example, RTC WebRTC has made the good decision that all media is encrypted and authenticated all the time, so they will never need to use opportunistic SRTP. Okay, next. So this is not a new topic. Many of you have been involved in previous discussions of this. It actually goes all the way back to ZRTP, where we called it best effort SRTP. And this was something that the industry many years ago recognized that we needed in the transition from unencrypted RTP to encrypted and authenticated SRTP. And there was a draft, the Kaplan and Music Best Effort draft, which was discussed a couple of times. And it basically lays out the arguments for best effort SRTP. It goes into a lot of detail, goes through requirements, and ultimately that approach is what is used widely in the industry today. Next slide. And we just want to, the authors, we wanted to dedicate this work to our good friend Francois Audet. Many of you knew him. He worked very hard to improve SIP and RTP security and was a co-author on the Kaplan Best Effort draft. Next slide. So why now, after so many years and after the industry has largely adopted this? A number of factors. One is in the SIP forum. In adding SRTP, we wanted to add a opportunistic or best effort mode, but unfortunately we have no specification to reference for that. The IMTC went ahead and wrote their own as part of the best practices for SIP security document, defines this and is implemented in a number of places. You know, these days opportunistic security does have some respectability. Here in the post-Snowden era, we know that more encryption is better, regardless of how you actually do it. You know, many years ago, best effort SRTP was very controversial, but hopefully it's not going to be today. And ultimately, the more internet traffic that's encrypted, the better. And with WebRTC and RTC Web, we're already generating a lot of that encrypted traffic. And you know, the approach just works, and it's nice to circle back and get this right. Next slide. So one thing we did talk about the authors about whether we should just publish the Kaplan Best Effort draft. We decided not to do that, to write a new draft for a number of reasons. One is that it's a fairly long and involved draft that makes a lot of arguments for best effort. And you know, today those are well summarized in the opportunistic security document. Also, the best effort approach defined in that draft is a little bit different. It's really best effort in the way you negotiate it. It doesn't relax the authentication aspects that opportunistic security does, nor does it make user interface recommendations as well. So technically it's slightly different. Also, it doesn't discuss the more modern keying approaches such as DTLS SRTP. And also, to try to appease some folks, the 0.1 version of that had some additional things added to it that nobody liked, relating to a specific payload for the SRTP and the like, so nobody wants that. But if there is interest, we could certainly publish this document or a version of it as informational or historic or something like that if we feel the need to basically document that ancient history. Okay, so in terms of the approach that we took in writing this draft, it's basically just a short draft that refers to the opportunistic security for the motivation and for the high-level justification. And it doesn't define any new attributes. It really just describes how to use all the tools we've got, but use them in an opportunistic manner. And specifically, it involves the caller indicating support for opportunistic SRTP by including SRTP attributes in the M line. However, they still use the AVP profile, so they do not use the secure profile in the M line, which is the piece that's caused so much trouble in the offer answer negotiation over the years. So that's in the offer. And in the answer, if the answer wishes to understands opportunistic SRTP and wants to use it, then they respond with SRTP attributes in the M line. And that's basically the indication that we have successfully negotiated OSRTP. So next slide. And it's important to recognize that this approach is not specific to any keying mechanism for SRTP. And in fact, it seems it's even possible to include multiple keying options in the offer as long as the answer only selects one. So that's a little bit of extra flexibility that it seems we can do as well. But it does relax the authentication requirements for those keying mechanisms. Now, if the authentication is there, then you definitely use it, but it is not a requirement. So for example, with SDP security descriptions, we still require the confidentiality. So you still need to use TLS transport, for example, but you do not need an authenticated signaling channel. And for DTLS SRTP, it means you don't need an authenticated signaling channel. Not that anybody ever has an authenticated signaling channel. But in any case, that is relaxed. So next slide there, just a very, very simple example.
Just Martin Thompson, the last thing you just said, I think is incorrect. We rely on having an authenticated signaling channel for integrity for DTLS SRTP. Or at least we require that we trust that the signaling channel hasn't messed with the fingerprints. Otherwise, we get man in the middle for free.
Correct, that's what the spec says, but
Which
in
is,
practice.
is that what you're? You can have real certs in the handshake. Which world does Richard live in?
Can you please go to the microphone?
Yeah, I get the point. I wasn't going to get into that point, into that discussion, yeah. But
Yeah,
I just wanted to put, like, correction for the statement, that's all.
In the original design of DTLS SRTP, it relied on RFC 4474 integrity protected signaling. And we all know how successful that's been. But the good news is that opportunistic security does not require it.
Yeah. So Jonathan Lennox, yeah, what I was saying off mic, and Mary correctly yelled at me, was that because this, OS, the point of OS is that yes, it might allow man in the middle attacks, but still a lot better than nothing. So.
Yeah, exactly. And that's why we're going to do all this, right? And if there does happen to be a way, say if there were someone were to try to revise 4474 and for some reason that actually worked, it would still be able to sign, right, these fingerprints, however they
Sure.
appear. You list 4 different methods for it. Today, RFC 4474-BIS really only talks about the ones relevant to DTLS SRTP, but I'm sure we could figure out a way to sign the rest of them as well. So I don't think this is like adversarial in any way, and let's not try to. I think these things are entirely complementary.
Yeah, no, whatever authentication you have, you can still use and you should use.
Magnus Westlund, you listed Mikey there. To my understanding, there were no Mikey method that can work in this type of opportunistic without some pre-secrets. Either search or some shared secrets.
Yeah, I think we did not list Mikey specifically because I don't think all modes would work.
Yeah, okay, in the draft it's listed.
Is it? Okay.
Yeah.
Okay. Yeah, some modes of Mikey may work, probably not all of them.
Yeah, you better check because
it would be good to know, yeah.
I think that is one of the questions, and I mean, I don't know if this is begging questions that are coming up in other slides. If whenever we offer a set of different ways to be able to do things and say the answer gets to pick, obviously there are concerns that arise from that, especially if some of the modes are problematic for various reasons. So, I mean, at least are there going to be a preference order, right? Like if you can't accept this, you should accept this. At least guidance along those lines, or are you going to talk about that at all? Or
No.
Okay.
Now's a good time. Yeah, I mean,
Okay.
that is something that we could definitely use some feedback on.
Okay.
Is that options. The goal right now is not to have a preference, to just list alternatives, and any one of them could be selected. So you shouldn't offer any that you're not willing to use.
Okay, so we as a group then should make a decision about whether we think all 4 of those options are appropriate, and if some of them are not, we might want to vote them off the island, in other words.
Yeah, we could rule them out in the spec, or just say that the implementer should not include them.
I mean, obviously the concern being, right, that if there's one that's really weak, and obviously the attacker's going to pick that, right? So anyway.
Okay, so this is a very simple example. Offer on your left, answer on the right. The offer has a fingerprint indicating that DTLS SRTP is desired as the keying method, and we see the answer comes back with the fingerprint, and in both cases it's just the AVP profile. Next slide. So here's an example where OSRTP is not negotiated, where there is a fingerprint in the offer, but there is nothing in the answer. So in this case, you just continue with RTP with no failures or error messages. Okay. All right, so now's where I read the charter word for word here. No.
Jonathan Lennox, I think one other comment that would be useful to have in the motivation section is the everybody hates CapNeg, which is that, technically you could do this with CapNeg. In practice, nobody has ever implemented it and everyone hates it. We need to have at least say, everyone hates it and explain why. And, in particular, because we want to make, the original motivation for CapNeg was exactly this, but somehow it spawned massive tentacles. So we want to make sure we don't do that again.
Right.
So
Yeah, the goal here is not to define any extensions to SDP or offer answer.
So I was just sharing here for a second. I don't think that we have any serious proposal to actually form a working group to go do this. We need to decide how to dispatch this draft, and they kindly produced a charter to explain what the scope of the work is, and it's useful for understanding the scope of the work and what we're talking about. But I think I'd rather try and figure. I think that the key question for us, and this is, I'm throwing this out as a straw man for people to tell us on, is, do we want to proceed with something of roughly this shape? And we all know this shape has been discussed for many years, and times have changed. The information is different that might cause us to want to move forward or not move forward, as we said. So are people fine with not discussing the details of a charter and sort of more moving into the heart of the conversation of effectively whether the IETF would do this work? If we decide yes, then we can move into the details of it. Well, then we're going to drop the problem on the ADs and figuring out where and how. But we can move. I'm sure we can figure out the right mechanism for where to do this work. The key discussion really, I think, is whether we do that. Is it? Yeah.
You have slides on that further down.
Just a very last slide.
Yeah, sure. So maybe we should just skip to your last slide on that.
Yeah, so I'm arguing that we really don't need to, we're not starting from the start here. We don't need to start with requirements and all those kind of things. We really want to document what's been done out there. But we could use some good security reviews. So whatever path we take, we need to get some good solid reviews to make sure that that we're not doing anything that we're going to regret.
Ronnie, Evan, just a question. I sent an email because, for example, RFC 5763 had section 611 about best effort describing using CapNeg. So I think if that's the case, then we need to update that and point that if we are going to take this work, we need to look at the other document and verify that this is recommended in the documents that are proposing how to do best effort security.
Okay.
Christer Holmberg, yes, I support this, and even though this draft doesn't define any new, SDP procedures or attributes, I think we're going to have to connect it to the DTLS SDP draft, which does that. But I think they're going to go hand in hand because there you have a new attribute and so on.
Okay.
Yeah, so I actually mentioned this in the sector lunch we had earlier this week and tried to get some security folks to show up. I'm not sure if we've really succeeded. But yeah, I think I agree that we should get some security eyes on this and try and understand what the overall impact is. I think we missed an opportunity when we wrote the opportunistic security draft to call it downgradable security. Because really what we're talking about here is something that the network can force down to the minimum offered. And so I hesitate to put this sort of thing for, I was disquieted when you put on the slide that someone was recommending putting this as a security best practice. Because, using this sort of thing as opposed to establishing requirements in a given ecosystem for DTLS SRTP or security mechanism of choice means that anyone in the middle of a transaction can force things down to the lowest security level possible. And I would hope that would not be the best practice.
Right. No, it doesn't. It doesn't replace the full security policies, which is the best thing to do. And for example, RTC Web and WebRTC, we're doing the right thing there. This is for the rest of the universe, which unfortunately, isn't starting from scratch, has a lot of deployed base,
Yeah.
and needs to manage a transition where you've got all different devices.
Yeah, so if we do something here in the security considerations, I think we should capture that and say, we are allowing you to negotiate among various options here, but you should make sure that you're okay with the least good option in whatever you accept.
Definitely.
Yeah, sort of in a similar vein, it makes me pretty uncomfortable to include things like SDES in here, because that is not, I mean, we saw in the WebRTC discussion, it's not really when we have the opportunity to move away from that. So it's a technology that we should be putting more effort behind. So I would feel more comfortable with this draft if that were not there and we had only things that had automated key agreement. I realize there's probably others in the room that disagree with me on that, but that's my gut as a security guy. And the final thing was I'm a little concerned, and I'm by no means an SDP expert, but I've heard there's a difference between AVP and SAVP. And I'm concerned, just knowing that exists, I'm concerned that if we go down the thinking through how this works, that we may end up adopting more of the complexity of the prior efforts and ending up with something that's not quite so simple. But I defer to people who understand the negotiation process better.
Yeah, we have had a lot of discussion in the past about the AVP versus SAVP. And in terms of restricting SDES, I mean, that's what most of the secure devices out there today use. So if we rule them out, then this won't be usable by everybody, essentially.
Jonathan Lennox, yeah, I think we need to have a concept of second best current practice. Yes. So I guess the one question, maybe the mechanism is a little out of scope, but I'm just worried about, especially for the SDES case, the early media, because you can't actually distinguish RTP from SRTP based on the wire format, and you really don't want to play out encrypted media as, say, G711. It would make you very unhappy. So, so we want to make sure that we have some notion of that. Obviously, if it's DTLS, you can tell if you get a DTLS handshake, but
yeah, we need to document the early media limitation. Right? We have discussed that extensively in the past, and mechanisms to fix that have not been any good. So we just need to document that as a known limitation.
Yeah. All right. So I mean, my first instinct for venue would probably be music, but I don't know if you get enough security people showing up. So. Oh, and the other thing I did want to comment, sorry, is that you say it didn't. Somebody claimed this didn't, do any new SDP attributes or procedures. It may not be new attributes. It's definitely new procedures. So at least in terms of what's standardized, if not what's there in terms of what's deployed.
It's a little bit high. Okay, Roland Jeske, Deutsche Telekom. As a general statement, of course, we support this work fully, and we had so many discussions about security and if security is the highest grade, but nevertheless, we have some use cases also where it's more important to get a call through instead of to have a secured call with regard to that. So we need some additional, let's say, procedures you described in your draft, and CAPNEC is an additional mechanism to be used and to be implemented. And that's the easiest way to go, what we see from our perspective. So full support from our side. Thank you.
Sorry, I misunderstood. It sounded like you said CAPNEC was the best way to do
No,
this.
we don't want CAPNEC. We want to have this approach. Sorry.
I was pretty sure that was what you meant, but I heard different words.
Thank you for the clarification.
Yes, Chris. No, I think this should be done in music because, in my opinion, what this is all about, it's offer answer procedures for opportunistic security. That's what it is. I mean, that's the name I would have given to the draft if I would have written, right? So.
Yeah, makes sense. Let's not get too focused in on the where it gets done. We can figure that out with the ADs afterwards. I think the critical thing to speak to here is, should we do it? Yes. Okay.
Jonathan, next, do we want to mark this draft as obsolete CAPNEC?
CAPNEC does a lot more. We could maybe just mark CAPNEC obsolete with no further discussion.
Okay, Charles Eckel, just in terms of should we do this work? Yeah, I would really like to see this happen. You mentioned the IMTC before, and we, came up with a proposal for how to do this based exactly as you'd said. And we've been doing this for, I don't know, at least 5 years. It's been working very well for us, and just didn't have the stomach to bring it into the IETF and see what would happen. So very happy to see you doing it. And I hope, I'd like to see this go forward.
Better you than me with the summary.
Okay, so let's go ahead and do the hum. Okay, so who believes that we should be working on this somewhere in the ARC area? Hum now. Okay, and who thinks we should not be working on this problem? Okay.
So it wasn't unanimous, but I think it was relatively strong for we should be doing this work. Yeah, sure.
No, what do I care? Same stuff I said before. I think that I worry that relying too much on this for deploying security encourages barriers to security to continue to exist because they can force things down. I think it's important. You can do this, like I said before, and Alan pointed out, you can do this and say, oh, I'm only going to accept a certain minimum enforcement level. And okay, in that context, maybe it's useful to negotiate between DTLS and ZRTP. Maybe there's some benefit there, but I think it's more useful in the communities that are trying to move to a secure state to actually establish minimum security requirements instead of leaving this negotiation thing that can encourage the barriers to security to stay around. And we see this in the web in terms of tolerating breakage. So, I mean, part of the reason that we don't treat HSTS upgraded links as not mixed content, as secure content right now, is because we want people to find their mixed content issues and fix them. And there's sort of an analogy here, like if we enable these things to be treated as secure, if we enable the calls to continue to complete even in the presence of these things that are breaking security, then the things that are breaking security will stay in the network longer because the calls still work.
I'm sorry, John Peterson, I'm not sure that's entirely incompatible with doing this work in the sense of, so if it turns out we need to vote some options off the island because we don't think that they meet that minimum security bar, I think that's a subsequent discussion to have. Now, if you believe there is only one that is satisfactory, and maybe that is your position, right? Then, I think I understood your response, Alan, to, well, there's a lot of SDES out there, even though a lot of people think SDES sucks, and if there's Mikey problems, as Magnus is pointing out. I think that is actually the tough part of this, is having that discussion about what we think is acceptable. But the notion that there could be this mechanism that has this negotiation capability in it, right, that we're just defining for SDP and doing it in something like mMusic, as kind of like Krista was suggesting, just a generic profile for doing that. I can imagine that being entirely separate from a BCP that says, by the way, here's how that fits into a broader context, the way that we would think people should do security per se. So I don't think that rules that out. I mean,
yeah, the three letters BCP reminded me that if we do this, I would prefer that this not be anything considered like a BCP, and at least in the IETF context. If other SIP contexts want to put some imprimatur on it, I would prefer this be, heavily caveated in for use in specific situations as transitional technology.
Sure.
Charles Eckel, I guess on the positive side, what I see here is that in a lot of deployments, securing the media was not being turned on because of a important percentage of calls would fail as soon as you turned on these security mechanisms. So a lot of people were just turning it off. Now, at least with this, it does allow them the mechanism to turn it on. Obviously, there's a lot of reasons why it's not perfect, but this way you can turn it on so that opportunistically it works some percentage of the time. And as more and more people start to turn it on in this opportunistic mode, then hopefully at some time in the not too distant future, you can go to the point where it's just on, and that's the only way, and you can't go backward. And even in the IMTC way, it's what we've said is that if both sides support it, and if it's mandatory, you obviously just turn it on both sides, and this never comes into play. But I think this just helps you make those incremental steps forward that weren't being made before.
Yep, exactly.
Alan Ford, I just want to echo that pretty much. It's, I'd love it if people went and resolved all these encryption problems in a network as they ran into encryption problems, but most people solve that problem by turning off encryption. It's sad but true. I support this work because it's just documenting what we're doing today.
Jonathan, the other thing I would suggest in the mechanism is that, we all, I mean, it seems like it's a relatively easy extension to do something like, say, use SAVP as the proto and basically do opportunistic DTLS. So, I'd rather do DTLS if you support it, but I'll fall back to in-band keys, which doesn't get me forward secrecy, but it's better, and so on. So I think it's a relatively simple generalization of the concept to support that. And maybe that's more than we want to do. Maybe that's the scope creep that I warned against in my previous comment, but
yeah, that's something different. That doesn't solve our problem that we're primarily trying to solve.
I guess sort of my underlying unease here, maybe this is just because I spend most of my daytime in the web, is, we've had opportunistic proposals like this in the web, and people get really confused as to if you do opportunistic security, do you get the lock icon, right?
Right. You don't.
Which you clearly must not.
Right. No,
and I'm
opportunistic
concerned.
security says you don't. You're not allowed to do any indications to the user.
Yeah, agreed. So I guess what I'm concerned about in this case, we don't have lock icons on phones typically.
Some do. Yeah.
Ours do.
Yeah.
Okay, so maybe we can be clear about that. But also for operators who are deploying networks, I'm concerned about them thinking they get security by turning this stuff on, when they're really just getting some incremental slightly less non-security.
Okay. Yeah, definitely no padlock or the phone equivalent. Yeah.
Okay, thanks, Alan.
Okay.
Okay, thanks, Jonathan. So, Mark, did you have something you wanted to say on the next topic? Yeah. Okay. Did you? Who has them? Do you have? Well, let me. You got them, so you want to? That's the document. No.
Bring your laptop.
Oh, I'm not. Here, you want to? Oh, yeah, well, exactly. Hide your secrets. Well, oh yeah, I do. Oh no, I know, I don't. What we call.
So I'm here on behalf of some folks at the W3C who came to us a little while ago and asked if we could start the process to register a font top-level media type. Next slide. And so what we're talking about here is not font Times New Roman or font Arial or font Dingbats or God help us all, font Comic Sans. It is things like this. It is formats for fonts. Just as an image, it is not image/picture of my mom. It is image/JPEG, for example. Image, oh, well, that's cat slash.
Cat/JPEG.
Cat slash, that would. So the process is how many weeks? Okay. Next slide. And so the draft, which is available and all can view, makes an argument for not making an application based on a number of things. For example, that application/star is often treated as suspicious by things like virus scanners, and fonts are not generally considered to be active content. And that there are a number of common parameters that they'd like to apply to all font formats. And also sometimes they have unique licensing and usage requirements in that world. Martin Thompson.
So on that first point, it was my understanding that these font formats were approaching Turing complete in the number of features that they have. I'm not an expert on this, but I've spoken to some people about this, and the number of things you can do with a font is approaching the point where suspicion would be entirely warranted.
Is that applying to all font formats or a specific one?
I mean, there are things in the application space that are perfectly innocuous by the same token, right? So,
well, certainly, PostScript is, not too far from fontiness. So, yes. These are just the arguments in the draft. Don't shoot the messenger. Next slide.
You're the only person I have to shoot.
No, we have fallbacks. We have a well-reasoned system of backup liaisons in place. You'll never get rid of us all. We had a very lovely discussion about this very topic independently on the Apps Discussed list around 2011, if I remember correctly. It went on for some time, and I reread the entire thread about a month ago. It seemed like the general feeling was, despite a few people who didn't agree, there was an overwhelming support for, yes, let's do font slash. Somebody should go write that draft. And nobody went and wrote that draft. So now the W3C has become interested in this. There's a relevant community there in the web font work. They highly desire this to happen, and so they took the trouble to actually write the draft. And so I asked Barry what the right thing to do was, and Barry said, take yourself to dispatch, young man, which is very kind. And so here we are. I don't know much about dispatch, but here I am. And that's all I have, I guess.
John Levine, it looks fine to me, but bitter experience says that media types need someone who's desperate to implement them. So I'm just wondering what the plan over in Webland actually is.
Yeah, so I have not caught up on that, but they at least the W3C staff I've talked to seem quite keen, and I believe that this is coming from their user community, folks working on font engines in web browsers and so forth and so on.
So they would like go out and fetch a font from somewhere to make your page look nice or something?
No, I don't know that that's the case. I think it's just they want to have a unique space for font formats. Again, it's not saying Times New Roman.
No. I mean, if you are a credible person, if you know people are saying, yeah, we're ready to implement this, then I think we should do it. Otherwise, it's going to be like the archive thing that came up a few months ago. Like, yeah, that was a great idea. Nobody had implementation plans. So,
well, but font formats already exist. And they're already implemented.
No. Archive formats exist too. Now the problem was nobody wanted to do nobody was willing to do the
transition. You're saying.
No, this was archive.
Yeah.
But I'm saying, but nobody said like here's my concrete example. It's like application gzip never existed.
Mm-hmm.
Until a few months ago, DMARC came along, and I needed a streamable archive format. So they said, okay, we'll do gzip, but now so we did it. So I mean, I don't want to hammer on this too much. I don't want to. If there are people who are ready to implement this and actually fetch MIME types and put it in HTTP stuff or something, then I think it's great. But if it's just like, oh, that would be nice, I'm worried about it being useless work.
Yeah. That is my impression, but this is not my particular slice of the world. So, yeah.
Sean Leonard. So, as somebody who's tried to implement a top-level media type and had some experience with this, I have a few remarks, right? Which is that we've tried over the history of the IETF to propose, top-level media types. I think this is actually the third attempt at defining the font top-level media type, because there was one attempt in 2005 or 2006 that failed. And as somebody who regrettably, really wanted the archive top-level media type to succeed, I accept my responsibility of not being able to push, being one of the proponents, not being able to push it through. But it goes to show that it's one thing to propose it, but I question whether there is enough interest, I guess, throughout the community to get it not from an only initial draft or initial couple of drafts, but all the way to publication. Because even though you say that there's a relevant community, there's also a relevant community for archive types. And actually, there's been relevant communities for font in the past. Maybe something that the IETF and we should think about is that the barrier to registering a top-level media type is too high, or the requirements that we replace on ourselves is too high to define all of the different permutations and parameters that we need to think about, before actually issuing the registration. So what I mean, for example, is that the top-level media type text has had a lot of additional parameters that have been accreted onto it, particularly text/plain, right? For example, there's the format flowed, del space, fragments, stuff like that. So my point is, why don't we have a short draft, just agree that, yeah, it's a good idea, let's make font, and then agree maybe we can have subsequent RFCs or publications that define more about what's in common for this media type. And that way it may succeed.
Richard Barnes. So just to John's comments about who wants this, I'm not going to have a definitive answer, but when Mark put up the slide and said something about active content, it prompted me to start thinking about the mixed content specs that WebAppSec is working on at W3C. And indeed, in their part of the distinction that spec makes between active and passive content is based on the top-level media type. So things that are marked as audio / or image / are treated as safe content to load because they're treated in safe ways by the browser. Now, as Martin pointed out, fonts are getting pretty complicated and they get loaded in CSS and things like that. So it might not be this might not be a safe thing to put in there, but you could see it getting used that way. And I think putting browser hat on briefly, we'd probably be interested in implementing that if it would help address people's mixed content issues. Agreed. There's lots of analysis that needs to be done. I know jack about fonts. So this is very provisional, but if that works out and if it would help people's issues, we would be interested in implementing.
Wendy Seltzer, W3C. And just to convey that, yes, there is an active web fonts working group with participants who are requesting this to solve use cases that they face. It's also not my area directly, but there are real people who are who would like to use this.
So other than Mark, are any of them going to come here and do work on this if we spin it up?
They have been doing the drafts over at W3C and sending them here. So whether they will come to meetings, I don't know, but they will participate in the discussions.
They do need to send them here. They have not sent a draft yet.
Yes, they have.
They have. Okay.
Yes, they have.
Relaying for Tony Hansen. He says, +1 to support font/star draft. We added model/star font shouldn't be more troublesome. It does need the relevant community to actually finish the work. If they don't, then it doesn't happen, plain and simple.
This is Barry. The model for when you want a top-level type is when there's something in common among the subtypes. That means that you would throw all of these at one particular processing engine to deal with. An application was a catch-all, but if you look at image, you often just say, okay, I have a special thing for image, banana, but anything else that comes with image/anything, I'll throw over at this image processing program that probably knows how to deal with it. And fonts, to me, definitely fit in that model. That and the fact that we have people who are looking at use cases for font top-level type says to me, let's do it.
So if I put my liaison hat on, I will make sure that I take back to that community that they do need to participate in the work here. I don't know that they'll do so physically at the IETF meetings, but that's fine.
We have other ways.
We all know. But I think, because they wrote a draft, I think they know that to some degree.
So Sean Leonard, so just a quick question. So if we accept the work, where does it go? Because dispatch doesn't do work.
That's
right?
why
So,
we're here.
Right. So where other than here? will it go?
The chairs could tell you this, but it either AD sponsored or a working group. We have no existing working groups that would fit, so we would charter a new working group or have one of us AD sponsor it.
We can also suggest things and recommend toward the ISE or other things, but this is clearly something that probably won't. Oh, for this particular org, it has to be standard track. So it sounds like the working group is appropriate here. So the next thing to do is start working on a charter.
So one of the things that we'd like to say about that too, that I think we did more in RAI and we hope to be doing more of in ART on this, is forming a working group shouldn't be hard or complicated, particularly on something like this. Let's make it quick and simple, write something up. We can get something on the mailing list. People like the charter. We should be able to have one quickly. This does not mean 50 hoops and 3 BOFs in 2 years.
It just requires more personnel.
You can do it all, Mark.
No.
No, look, we need somebody to just drive through some charter text that would have a bit of experience on it. We'll get the people involved. We need the people who are interested in doing the work to be expressing that interest and saying what they need the charter to say so that they can keep the world scoped and narrow and not boil the ocean. And somebody needs to write that up. We can help that. And then our ADs need to look at it and think that it's, it seems like between 2 of the 3 ADs at the front here can't spell their own name. So, that's a sort of, sorry, we're charging. Yeah, so we get that AD cert. Yeah, no, another title. So we get that done really quickly and then put the draft forward, start moving it forward. And I assume this will be a working group that does most of its work virtually. Yeah.
Or all.
Yeah. Sure. Does that seem clear? Happy?
Okay.
You don't look happy.
No,
Okay, so for the minutes, Mark's happy. Sure, if it's got a draft.
So I apologize for the late notice. I got confused about the states. In my defense, I'm new to this, at least to dispatch. There is another draft that's been recently submitted by Mike West from the Web AppSec Working Group in the W3C. They are requesting a registry for CSP directives, content security policy. And it is literally just a draft to establish a registry. Very, very simple and straightforward, I think, because they just need a registry, and W3C doesn't have the capability to mint IANA registries on its own. Personally, I would love to see that just because it'd be great to see some of the web folks buying into the whole registry thing. Yay, registries. So we need a place for that to go as well. And I kind of, in the back of my head, wonder if because it is such a mechanical process thing rather than anything that could possibly ever be contentious, whether that could be AD sponsored. Yeah, I know.
Well, so this falls under our new charter as something we can do as an IANA housekeeping action if the ADs approve us handling that.
It is very housekeeping-y, yes.
This is Barry. I can't speak for my co-ADs, but I would leave it up to the chair's discretion whether they think this fits in that. And I'd be happy to AD sponsor it if they don't. It's the sort of thing that I would normally say ought to be done in the independent stream, but we don't want to be creating new registries in the independent stream. So informational document in the IETF stream sounds like the right thing.
Is that an official thing, independent stream, no new registries?
We have pushed back on that before. I suppose I would not object to an independent stream document creating a registry that had a policy of IETF review or something, but that would seem a little weird.
It's kind of buying into something you might not want to buy into, yeah.
Alyssa Cooper, I just opened the draft 5 seconds ago, but see no reason to do this in the independent stream. So I think we have some other path for it. We'll look at it further to figure out what that path is, but.
Happy to take it to the list,
So perhaps we could ask people to read this, send comments on the list, but this looks like.
Yeah, I wanted to do more of a heads up.
It seems like a good opportunity for us to be able to dispatch quickly.
Yeah, +1. This seems fine to me. Might in the long run be worth. Where's Wendy? Wendy, she's still here. Anyway, Wendy, might in the long run be worth getting. If we can get these web folks addicted to registries, might be good to get W3C a more direct relationship.
So Mark, when you sit back down, can you post a note to dispatch working group pointing to this document, please? Okay. Alrighty, so we're on to the next topic. So Kern's going to drive it from his computer. We're making an exception here because he's got a demo part of it, so he doesn't need the white dealing on.
Oh, for the archives?
Well, I don't know if we can upload this. Currently.
Yeah, I think we can, yeah.
Oh, okay.
Yeah, some formats we can.
Hi, everybody. My name is Koen de Schepper. I'm going to present some work in the context of a European FP7 project, reducing internet transport latency. It's about ultra low latency delay for all applications. It's together with Inton, Olga, and Bob that we did the work. So today we have fast devices with interactive applications. We have super fast, fiber fast, low latency networks, and we have nearby data centers with huge processing power. So I guess we all have real low latency experience on our devices. Well, sometimes, but not always. And the reason is that we still have a kind of old timer in the middle between the super fast networks and our applications. And that's the classic TCP congestion control. There exist better solutions, but they can't be deployed. So there is what we call L4S, a new family of low latency TCP congestion controls, and that are scalable, low loss, low latency, and scalable. But we can't use them. But if we could use them, I can show you how the experience, what the difference it makes to an experience when they are used. So I'm going to start the video. I don't know whether the METEC people can see the link already, or is it?
No, this is the problem.
Yeah, so they're on the rightproject.eu/DCTTH, from data center to the home, /1511, the date, dispatch working group.
Oh,
it's on the mailing
okay,
list.
that's
Okay.
fine.
Yeah.
Okay, for people remote, you're not going to be able to see the video he's going to play, but there is a link to it in the mailing list, and we're trying to get it uploaded to the meeting materials right now. But yeah.
So what you'll see is two touchscreens where an interactive application which sends the finger movements to the clouds, and in the clouds the correct viewpoint is selected and on the fly encoded and sent to these laptops here. And you see the right one is using a classic TCP and the left one data center TCP. They are identical, so going from an identical laptop to an identical server over the same bottleneck with background, a few file downloads, 3 on each pair. And I hope you can see clearly the left one sticks to the finger, as you could say. The right one is a bit more jerky and has not the right experience. So it's the same application, the only thing is a different TCP. So if we could use it, it makes a big difference. So normally if there wouldn't be file downloads, actually the experience would be the same because there is enough bandwidth. It's just that in the right case, there is a lot of queuing building up in the network, which are required. And on the left side, there is actually no queuing. So what did you saw? Well, actually, it was a demo on a real broadband network with a base round trip time of only 7 milliseconds, so it's close by. We had heavy background loads, 6 parallel flows, actually 3 per pair. And we used the data center TCP, maybe you saw it, as an example. It's just available there and actually it behaves as a scalable TCP. It wasn't necessarily designed for it, but it's available and we could use it. So it's available as is under Linux, the latest release, and also on Windows Server. So what we didn't do was, it's not quality of service. We didn't do anything because that's at the expense of others. It just gets priority and the others have less. So it's available for every packet of every application, even file downloads you will see later, and all have hardly any queuing in the network. In the network, we have to adapt the network for this. But to do that, we only look at IP headers. So we don't need flow identification. We don't have to inspect transport headers. And we also don't use DPI or whatever. In this solution, we use 2 queues. There are other solutions like FQ, which uses a queue per flow. And that needs to identify all those flows. So if you have a tunnel, it's hard to see whether there are really subflows in there. So with this solution, it's also not needed. And by the way, if all the TCP traffic is moving to this, it will also still work. So to demonstrate, well, on the next slide, you see the setup a little bit. So it is a real, we took this video when it was on a real equipment, let's say. It's a real residential gateway with a real copper line, with an access node, several hops of service routers, and only at the BNG, it's a function in the network, in the aggregation network. Where typically the per user rate limiting is done, we took the traffic out and put a Linux server where we could replace the AQM. And that's the trick. Okay. Maybe first explaining why dispatch, why we are here. We don't want to ask to dispatch work. We just want to show and explain the benefits to applications. But maybe as you know, it's not so simple because we have now a solution to make this better TCP compatible with the current internet, but it needs, of course, support in the network. So to have this work done, we need 3 working groups in the transport area involved. And it's both changes in the host and the network. Well, actually, especially when it's in the bottleneck of a network deployed, it will bring the benefits only then. So our question to dispatch then, as customers of the transport areas, are these benefits you will see later useful? And especially the harder question, is it useful enough to overcome the chicken and egg deployment problem? Because as long as there are no network support for it, there is no benefits if applications or your operating system is supporting it. And in the other way, there is not really a gain if we support it in the network if there are no applications or operating systems supporting this. Okay. Maybe quickly to show you very fast what is needed in the network. We have two queues. The blue one is for the new traffic. The orange one is the classic traffic. The blue one is a very small queue, and it uses ECN to be controlled, and it gets priority scheduled. And the classic one needs, classic TCP actually works better if you have a big queue, or a rather big queue. That one is used to measure the level of congestion. And with that level, we mark, and we also do a compatibility swap to have a correct drop, which is appropriate, because this new TCP needs a lot of marking to be controlled, so it's actually very aggressive if you use it normally. So we need more marking than dropping. And it's a very simple thing. We only use two random variables. If you want to see details, it's at the end of the presentation in the backup slides. So I'm going to show you another demo where I'm going to log in to this testbed, which is located in Antwerp. And on this AQM server, where the AQM is, we have a GUI where we can show what is the queuing size in the classic queue and in the data center TCP or the L4S queue. We also have control on the two clients where we can start file downloads, and you see the throughput, and we can also start some more interactive web downloads, which are more bursty. And we can see the difference on the behavior of both. So it will be something like this. So again, for the people in MeTech, we have a video on that page. The second video, which is a recording, so it's not the same as I will do, but hopefully it's fast enough. So this is a remote desktop. So the real thing happens in Antwerp. Here it's only the display which is remotely. So there is a little bit delay because it doesn't use the good TCP yet. So what you see here is the two clients. This is the blue client, let's say, the new TCP. This is the classic TCP. And this is, oops. I'll have to make the screen a bit bigger. Okay, so here you see it's the table which is moving. The queuing delay. So let me just start a few flows here. So now a few file downloads will be started on the scalable, on the PC, which is using the scalable TCP. And here there are a few flows started on the PC, which is using the classic TCP. And you see the throughput. So what you see is I get the same window, the same fair share, let's say, TCP fair. They are running TCP fair. And what you see here is a CDF, an inverse CDF of the queue size. So this queue size is hardly having anything in it. So it's 99 percentile is below 2 milliseconds. On average, it's 0.1 millisecond, the queue size. While the classic queue is here pretty good. It's configured according to a modern AQM, let's say. It's around 20 milliseconds and a 99 percentile of 50, below 50 packets, milliseconds, sorry. What you see is, for instance, it's more clear if I start, let's say, 10 flows on every client. What you will see is that the data center TCP flows, once they're up and running, they're all pretty much having a stable fair share. While if you look at the classic TCP flows, they go up and down, and sometimes they get for 1 second, because these are throughputs per second. So per second, they vary quite a bit. They go very low sometimes, and also can overshoot very big. In here, what you also see is there is a drop probability, because there is a lot of latency and our queue is only 30 milliseconds. We need a drop probability of around 7%, which is pretty high. Well, actually, here we use ECN, and the marking probability is 60%, which is even higher, but it doesn't harm the flow because it's marking the packets and not dropping packets. And because of this high marking probability, it's also the reason why they are so stable, because they get a lot of information and they can smoothly adapt to the rates and what is available. Another thing I can show here is web page downloads. So there is a load generator which is generating file downloads, 100 downloads per second. And actually for each connection, for each object, it's using a new connection. And what you see here is the object size from 1K to 1 megabyte on a log scale. And the y-axis is the completion time from 10 milliseconds up to 10 seconds. What you see is that our blue one, all the small up to 10K, all the downloads are below 40 milliseconds. What you see here is that with the classic TCP, all the downloads are above 40 milliseconds. And what's worse, because of the pretty high drop probability here, around 10%, there is a lot of loss of the final packets, and that are only retransmitted after 200 milliseconds. And also a lot of initial SYN packets which are lost, and they are only retransmitted after 1 second. And even multiple times, maybe if I reduce the load a little bit, we get to, because a bit less load, but even then, I can normally clear it. So you see the new situation. Even then, there are a lot of timeouts. So this is what you experience if you're downloading a web page. Sometimes it works very fast, and then your smartphone or your laptop is downloading in the background something, and then suddenly you have to wait 1 second up to 10 seconds before a page is fully loaded. So it's really unreliable. While in the other case, imagine if you would have your web browser here and you press to another page, and they smoothly and reliably are downloaded. Okay. Maybe another thing I have to show is, what if there is no normal traffic? I'll just stop the classic TCP. It's not because there is classic TCP that it works well, because if I stop it here, and I'll reset everything to make sure there is nothing running here, you see the queue is still very small, only 1.5 milliseconds on average, and the 99th percentile is about 6 milliseconds. You see, so if everybody is now using the new TCP, it still works. We do kind of priority scheduling, but that's just because the new TCP is worth having priority, because it supports low latency and it doesn't harm the other traffic by getting the low latency. It's the opposite way that the classic traffic usually harms real-time applications. Okay? Any questions up to this level, or everything is clear up to this level? Maybe we can continue on the presentation. So I think mostly I've said this on the next slide, and then on slide 13, another example, another test that we did was with adaptive streaming, HTTP adaptive streaming. We included Windows clients and server, just running the IIS media services for smooth streaming. And so we could configure the Windows client and server in either compound TCP, which is a Reno-like, an improvement on Reno, or in data center TCP, which is normally by default automatically if you deploy Windows Server in a data center. but you can also configure it to run over these links. So we did a smooth streaming download in parallel. So in data center TCP, in parallel with 10 flows of Linux data center TCP flows, and did a capture of what is the quality levels that were selected for the video. And then the same we did with Reno traffic on the Linux PCs, and the data center, the Windows PC was also in the Reno-like congestion control, the classic congestion control, the compound. And here you see the results. The first row is the quality what was selected by the player. So the player sends the download speed, and based on that, it decides which quality is appropriate without freezing the video. You see it goes to 1500, and sometimes it tries to get to the 2 megabit, which is more or less the fair share it should get. In a second, so the reason why it doesn't go up to the 2 megabit is because normal TCP, and you see that in the second row, you see there the 10 file downloads, and in the last row you see the throughput of the dash or the hash flows. You see they vary a lot, the file downloads, and also the video segment downloads will have this variation. And because it doesn't get a reliable throughput, it doesn't dare to take the highest level because it's not sustainable and it might freeze in the future. So this other solution with FQ is a flow queuing, which makes a queue per flow, and you just do round robin scheduling in the network. You see at the second row that it has for the file downloads a perfect fair share. It's a smooth line. There is no variation because every queue has a big enough buffer, so there are always packets available. But the result on the dash flows is what you see in the second row at the bottom, is that all the tops are gone. So it's not allowed to burst anymore, because then it gets in a queue in there, and it's only when it doesn't get scheduled, when it doesn't send anything, that it loses throughput. So you see the throughput goes even below that. While with the data center TCP, the variations are very stable, and also when it is downloading the video, because it's also every 2 seconds that it tries to fetch a new segment, then it gets immediately the fair share, and the client detects this and will finds the reliable throughput and will select always the highest quality. There is actually one higher. You see it even doesn't try to get that high, because that was around 3 megabit, and we had 20 megabits line with 10 to 11 flows, so that should be the right quality that it should select. So this was a little bit the results. They look very promising. Maybe if you have applications that can use it, you can evaluate it and try it yourself. Data center TCP, as I said, was available on Linux and on Windows Server. You can configure it with a default red AQM, normally data center TCP. If you want to try ours and see the fairness to other traffic, you can contact us. We can collaborate in that. But I would suggest try it for your own applications. If you have real-time applications, see what it does. Okay. So I come back to the questions. Do you think this is useful? I think the benefits are there, but do you have an opinion on whether it's enough to overcome this chicken and egg problem?
Right, and just to be clear, this is an informational thing for dispatch. We're not making any decisions whatsoever on this in dispatch yet.
It's just to get your opinion on what do you think as an application developer. Will this be an improvement? Is it worthwhile fighting for this? Or
I'm just curious what this looks like from the application. Richard Barnes, curious what this looks like from an application point of view. Is this the sort of thing where you would want the application to explicitly signal that, hey, you should use this high intensity algorithm, or is this something the transport stack might just do for me?
So normally it's perfectly possible that all TCP stacks are upgraded to use by default this way. And if the network is not supporting it, it detects drop and it will respond as normal TCP. So the Windows data center TCP does this automatically. If it finds drop, it behaves like Reno. If it finds marking, it will behave like data center TCP. So there is normally only a change in the operating system. Applications don't have to bother anything. They don't have to set what is my priority. They don't have to set, I want to use it even. So it's very easy and everybody gets low latency.
This is Ben Campbell. I mean, what you've shown is interesting. I don't think this room is the room that can tell you if it's a good thing to do or not.
Right, I mean,
If we
that's what I
we
said.
can't judge the cost or the implications, really, this is a TSV thing. So yeah, if TSV worked on this and it did all the stuff you showed and it was for free, oh, it looks beautiful. But I don't know what else we can say about it here.
Well, of course, it's a transport area decision, but whether application developers would support this or would find this a good feature is important to know. So that's why, first of all, we want to inform you that this is possible. But I agree, it's hard to take a decision, but.
Andrew Allen, so just following on, I think, from Richard's question. So does it require support at both ends to get any benefit?
Yes.
So is this something that we really need to negotiate to use in order to get a benefit? Okay.
Well, it can be built in the TCP stacks. Also applications which do it at the application level, of course. If you have UDP-based congestion control, you need to do it at
But
that
both
level
client
as well.
and server needs to
But
support
both
this
client
sort
and
of same
server
stack.
at least the server needs to echo the right ECN signals back, or the client needs to signal it back so that the server or the sender can use the signal from the network.
Okay. And then the other point you mentioned at the beginning, you said there were other improvements out there, but we can't use them, but that's all you said. So what are the other improvements and why can't they be used? Because I guess maybe some of the pushback maybe that you're getting is because there are other solutions in IETF that have already been developed, and so people are saying, well, use those, but maybe you can explain why they're
Well,
not suitable or why they can't be used.
I don't know where did I mention that?
I thought near the beginning of your presentation, you said there are some other improvements out there. We'd like to use them, but we can't, or something to that effect.
Well,
But maybe I was confused.
I was talking about this. So I was saying today we have the classic TCP, and there is better solutions, and this is one of the, well, the scalable TCP is a better solution, which exists, like data center TCP is implemented in Windows and Linux, but we can't use them on the internet now because the network doesn't support it yet.
Bob Briscoe, perhaps there's one bit of information you missed, which might be why people are confused. The existing solutions like data center TCP exist, but they can only be used in data centers because they're too aggressive. If you put them on the public internet, they'd push all the other traffic out of the way. And so what that dual queue system solves is it marks them more aggressively so that their more aggressive behavior gets pushed back more aggressively. So it balances back. So they work the same as TCP as far as sharing out the capacity goes. So at the moment you can't use them, but with that queuing system, that means you would be able to use them.
So I think to wrap up here, what I think we really wanted to have happen was get you guys to show people this, people who are interested and find out more, and do, send the pointers and the stuff to the list where people can find out more of this. And I hope you guys recognize both of these guys. I'm sure they're willing to talk to you more about it if you want to figure out how to put it in an application. Does that sound like a good conclusion?
Yep. Okay.
Yep.
Thanks.
So we got one last little topic we need to switch back to for a second. That's really about how efficient this new art area is going to be.
Can I just add, for more information, the link I sent for the videos, there's a whole page there of the drafts involved and all the rest of it. So, yeah.
So as a demonstration of the newly constituted dispatch chair's team and how efficient we are, we took Mark's idea of a CSP registry and we put it retroactively in a draft called Draft West Web AppSec CSP Reg 03. We arranged for Barry to sponsor it, and it's in last call closing Monday. So. Oh yeah, are you really?
So dispatched that in -2 weeks. It was really cool. And
no, Richard, you can't have a document.
The document.
You might say that dispatch dispatched it with dispatch.
You might say that's Richard would certainly say that. The document shepherd and the responsible AD both totally forgot that this happened.
We've also created your font working group. Just kidding.
I think with that, it is definitely time to get drinks before the plenary. Thank you all.
Yes, we are.